It's about infrastructure for slackline parks. And in this case, we are talking about mainly about anchors for parks. We will divide it a little bit into different use cases. For example, for beginner lines, anchors for long lines or jump lines, anchors for highlines, highlines and midlines, and of course also for rodeo lines. Highlines and midlines are not the usual slackline parks, but since it also happened that, for example, in Molisson, there are permanent anchors built, man-made anchors. I also added this topic here. And for example, we can divide it into different durations. There are mobile anchors, there are temporary or semi-permanent anchors, and of course, there are also permanent anchors. Normally, parks are only permanent because when you want your city to build something or your local community department, they only want permanent stuff. But since for festivals or for workshops or for shows, some temporary anchors are also quite common in use. So let's start off with the beginner lines. They usually have a very low anchor heights, below 1 meter usually. They have short distances. They are quite easy to use. Some of them are so thin that you can even take your end loop of your beginner slackline and wrap it around without even have to girth hitching it. And their forces are mostly medium or low forces. But of course, when you rig a chip line on it and you jump on it, you can get higher forces. But in this case, we're talking about the usual case. So where did it all start? It started on playgrounds with some balance systems. For example, in this case, with 3 ropes tied together. These were the first systems which were used in parks, and that's why we also added them here. They are also within the playground norms, which is very important for permanent stuff to be always taking into account the norms to calculate all of this. Because usually an official park is calculated by a structural engineer or geotechnical engineer. Here we have a park for beginner lines. As I already mentioned, here is a very short steel pole. It's a maximum 1 meter above the ground and has a small concrete foundation underneath. The concrete foundation for this should be around 1 to 1.6 meter deep. It also needs to have a little bit of weight to resist the forces. These small systems have a lot of advantages, but of course also disadvantages, which we'll get into soon. Steel definitely is quite a good material for permanent stuff because it doesn't degrade so fast. And I hope you can see my mouse here. You can also make them interchangeable. So in case the steel pole gets damaged or something, you can only interchange the part which is above the surface, and the lower part, the foundation, can stay in place. So when you have to interchange a pole, you don't have to dig out the whole foundation. Also here are some more pictures. As I already mentioned, the end loop can be placed directly above the beginner poles. The foundations can also be reinforced by rebars in this case, so the foundation doesn't rotate that fast. And usually they have very low heights and low lengths and short lengths. Another material you can use for beginner lines or for simple park lines is wood. It has the big advantage that it looks, for most of the people, it looks more aesthetical. Because a lot of cities, a lot of local communities, departments, they don't want to have steel in their green parks, which is kind of understandable, but wood is unfortunately way less durable. Also, it has usually a coating on the surface, which is also not that economically friendly. Especially when on the top of the wooden pole here, if the rain can come inside, if there's no protection from water, the wood will dry, it will get wet, it will dry, it will get wet, on and on. So the wood works. And in our experiences, after 5 to 10 years, the wooden pole already has to be replaced. So it's even some kind of semi-permanent anchor thing because it has to be replaced so often. And since often the wood is placed into a concrete foundation, the whole concrete foundation has to be digged out and the whole thing has to be replaced. So wood is not the ideal thing as long as it's not protected properly. On the right side, we have here a slackline park system from Cologne in Germany. This is a steel pole system with a wooden cladding around. So there are just some wood bars around it, which makes it also look way more aesthetical. In this case, we can even see that there's a small metal plate on top to protect it from water coming inside, from too much water at least. And the wood around can also be replaced without having the need to exchange or interchange the whole pole system. Another material which also can be used is concrete, like in this park in Ontario in Canada. It's also maybe not the most aesthetical thing, but this is a matter of opinion, a matter of taste. And since some people were running into the poles at night, they placed some of this red color on top. So it shines a little bit in the light, it reflects a little bit. And it's also not the most aesthetical thing, but it's definitely very durable as steel, so you don't have to exchange it too often. Another very basic system are mobile systems, for example, slack racks, like in the picture on the right side. They also have very low heights. They are usually for beginners to play around, for rehabilitation reasons, or for kids and elderly. The distances are usually even shorter, with 6 meters or below. They are also very easy to use. Usually they're made out of wood or steel. Depending on how heavy they are mobile or semi-mobile, and they have medium forces inside, or even low forces. There are different systems. For example, here the Slackboard from Blackbird Fun, I think is the company called. It's a 3-piece system which you can fold together. You can call it folding. It's very lightweight. It has 2.4 and 3.5 meters of length. Also the Slackspot system, it's reinforced with a steel bar on the bottom. It's only made for children with weight up to 60 kilograms. So nice small little system which can be set up very, very fast. Also the slack rack, the classic slack rack, who has never used it before, and out of steel. And the G-board, it's a flexible construction, also something new from Gibbon. It's also very fun to play around, although I have never used it before, but it looks very fun. And of course, there are also the self-made slack racks. For example, this one which was also used at Burn City Slack. It has a nice plate on top. It has a wide stand, so it's very stable. They definitely put a lot of thought in it, as you can see. And with these systems, you can easily build your slackline parks or small workshops. Another new system is from Blokes, as we can see here. It's, as the name already says, it's a concrete block. It has a ratchet hidden inside here. It's also locked with a lock. This system is something for permanent installation, for example. So if you want your city to build some more slacklines into parks, into somewhere, doesn't matter. This is a very nice system. It's very durable for vandalism because you often have drunk people around. It's permanently accessible, and there's no groundwork necessary. So all you have to do is place these blocks, rig your slackline, lock it, and that's basically it. So it's a very nice way to make short beginner lines more accessible for people in and around the city. Another thing are indoor slackline parks. Here we have again the pole system from Slacktivity, which is easy to use. Also, you can use A-frames, like in this case, to get more height. Of course, it's important that you check how much can this anchor point hold. This is usually some information you can get from the school or from the gym hall, wherever you try to rig your slackline indoor. Or also you can use as an A-frame these blocks, these gym blocks, but always protected, otherwise you will get some unbeautiful marks around here, as we also experienced. And of course, there are also trick lines possible. Here you can see the trick line going from this anchor to this side. In this case, we have poles in the corners attached here. I think they're also attached to the wall, or at least I guess. So also indoor tricklines are possible with very high tensions. And another thing is a very beautiful thing are parks at beaches, slackline parks. In this case, you can see normal wooden poles being digged deep into the ground. If you ever dig a deep hole into a ground, you know how much work this is. So it's quite an effort. And one thing you should consider when placing poles in parks, that you try to compact the ground around the park, around the pole, maybe with a vibrating plate or by foot or something. This gives a lot of stability because sand is not like concrete, of course. Sand is like gravel. It deforms a little bit until it deformed so much that it settled down and is really compact. So as we can see here, the poles here, they are a little bit tilted sidewards as the pole back there. I'm not 100% sure, but I guess it's because that it had to settle first. We made the same experience with gravel foundations for slackline poles. It just takes a few days, a few weeks, a few sessions before it settles down and doesn't move anymore. And here we have another picture of a park with steel poles, I think. Yeah, simply a beautiful thing, beach slackline parks. Except of beaches and parks, it's also possible to make urban slackline parks, like in this case. We have a lot of parallel beginner lines here and also some trick lines. Looks like it's for a competition plan too, with parallel trick lines, so really sick project here. Next, we have anchors for long lines and trick lines. One thing, trick lining, okay, yeah. One thing which is very important here is that you are way higher. When you're way higher with your anchor point, which this means that you also create a higher momentum. And this higher momentum is often the problem, the major fact in this case, when you dimension your pole or when you dimension your foundation. A small example here, if you rig in 1 meter high with a slackline force of 10 kilonewton, you get roughly 10 kilonewton meter of momentum force. And when you make it 1 meter higher, so twice the height, you can also get twice the momentum here. So 20 kilonewton meter for one normal foundation. When you try to stay within the norms, when you try to take the norms into account, then 20 kilonewton meter is for a 1 cubic meter foundation already the border. It's even too much, a little bit too much actually. But it always depends on what kind of norms are you based on and what are you calculating exactly. I just read trickline forces can also be up to 28 kilonewton. Please note that this is just an example here with the 10 kilonewton. It doesn't mean that it has to be 10 kilonewton. But during my bachelor thesis, we once also made testings on a 75 meter long and 2 Dyneema long line with 2.5 meter high anchors. And we reached the top of 10 kilonewtons by bouncing. So 10 kilonewton is definitely something which you should take into account also for long lines and for trick lines even more. As Tom already mentioned, during my bachelor thesis, I made some experiments, some plans for a wooden pole system. The problem with wood compared to steel or the concrete is that it can't hold that much forces, that much shear forces, that much momentum forces, and so on. So in this case, if you want to have a long line rigged on top, which can hold up 1 ton, including the safety factor of 1 to 5, in this case, we have then 15 kilonewton of force coming here. You basically need a stiffening pole down there. And this makes the maximum momentum of 15 kilonewton or less. And here you can also see the normal forces and the maximum deformation of 3.7 millimeters. This is also within the norms. This is okay. And here is a short plan. This whole pole system was planned because with our city we wanted to have it built. They wanted to help us to rig a longline park, to plan and build a longline park. Unfortunately, because of liability reasons, they backed out because everything above 90 centimeters height needs a special system, special fall mats or something like this. So this was never built. In this case, we have one pole here, and we have these rings around here, as we can see on the top view here. These are normal concrete rings. I think they're called manholes in English. Nearly every city department has this stuff laying around. It's filled with gravel. I mean, after the pole was put in, of course. Gravel also has every city. And the poles itself are out of Rubin wood. Rubin wood is one of the most strongest woods which is out there. There are also very strong woods, but they also have some down points. So usually cities or local communities want to have Rubin wood built. It's placed in here. It can hold here a little bit, but not too much. And the stiffening poles goes into another foundation, which is out of concrete now. And this connection here is done, for example, with some small steel plates. There are already quite a few companies who produce plates like this. One plate is attached to the wooden pole here, and one plate is attached to the foundation here. And it can easily be connected together by a simple turn. So this can transfer a lot of normal forces, a lot of shear forces, but not so much momentum forces. So no rotation can be transferred here. And that's why it's built like a triangle, something like this. Same goes also for two long lines from one pole away. In this case, you have two stiffening parts. And in this case, you can also simply use one of these plates down there, because you also have this triangle here, which stiffs out, so you don't have to transfer momentum forces down on this point. But you don't have to need two foundations for longline poles. It's also possible with one simple foundation. In this case, it has a foundation area of roughly 4 square meters. It's a product from Slacktivity. Here you can also see Tobias presenting it. And it is 2 meters wide and 2 meters broad. Altogether, it has a roughly 5.5 cubic meter of volume, which gets filled with concrete or with gravel in this case. The black part or the dark part here is concrete, like good concrete. Down there you have poor concrete, I think it's called in English, Magerbeton. And here it's filled with gravel. The pole itself is 3 meters high. It's out of steel, so very durable. And it's so strong to this big foundation that even on the top, you can add a force of 12 kilonewton, and it's still within the norms of the Slackline North and within the playground norms. But it's a really huge foundation. 5.5 cubic meters is really needed to be possible to make it like this. I also calculated it by myself, and it definitely holds up. Compared to this system or this system, it needs around 3 times as much volume. Another trickline pole system is here in Viña del Mar. I hope I pronounce it rightly. It's a trickline pole tilted against the direction of the trickline, so the trickline goes in this direction. It's out of steel, I guess. And therefore it can hold up very high loads, and when it's embedded the right way and also tilted the right way, the foundation, the embedment can also hold up the forces. Another system we have here from Bern in Switzerland with the waterline poles. I honestly have never seen them before. They look quite sick. Would love to try. Great thing here, I guess they are tensioned to the back in this case, most probably.
Actually, the special thing about these poles is that we couldn't tension them to the back because there was no space. So it's a very strong foundation with 4 steel rods going underground about 3 to 4.5 meters. And in the next pictures, you will see a picture of the foundation itself. They're still under construction. This is the dirt pile we created to drill the holes. So we had to have a company come and drill these 4.5 meter holes, 4 of them. And when you go to the next picture, you can see the actual foundation and the pole that is being lifted in. So these are currently still under construction. I just was on the line for the first time 3 days ago, but we still need to tweak a little bit. So this was a big challenge because we basically don't have the space to go to the back with any like tables and so on. Maybe temporarily, but definitely not permanent tiebacks. So the foundation has to be super strong.
All right. Yeah, no, it looks very massive, definitely. Do you know how much it's calculated to hold up? Which force?
Yeah. Again? So Yoshi calculated it's 128 kilonewton meter.
128. Jesus Christ, that's a lot. Okay.
So the pole is 6 meter high, and the idea is to also rig midlines of this over the river, not only rodeo lines and normal water lines. So in the winter we will use it as a midline spot, and in the summer it's a waterline spot.
Yeah, that's next level shit. Nice thing. I hope I can try it soon. All right, so let's go on. Another thing, quite an easy thing in this case, are anchors for rodeo lines. They have higher anchor heights, but they have way less forces. So low tensions are inside the systems. The side forces are more diverted, but as I said, they are very, very low. So usually beginner park pole with the red line marks the maximum height you should use the park pole. But for rodeo line, it's still enough because the forces are so low. Another important thing to mention shortly are the park layouts. If you have 2 poles, you can rig up to 1 line. If you have 3 poles, you can rig up to 3 slack lines. Of course, if you place all 3 poles in 1 row, you can only get 2 slack lines out of the 3 poles. And yeah, with different variations, you can get a park system layout which fits you the best. This, of course, depends on, do you want to rig as much slack lines in the same time as possible, or do you want to rig as much different lengths as possible, and so on. So a system like this with steps from 4 to 6 to 8 to 10 to 12 meters is great for beginners to get started and to always get on a little bit longer line. Also short view to temporary and the semi-permanent anchors. They are usually only usable for a few days, weeks or months. They are quite cheap and fast to set up, and they have a less impact on the environment, on the surrounding environment. They can be done with earth screws in this case, or I'm not sure again how this thing is called, but it's also a system to embed it into the ground. You can use, as already mentioned, the earth screws. These earth screws are between 50 centimeters and 1.2 meters long, at least what I have seen until now. When they are that deep into the ground, the tensions into the ground get always higher and higher. So the deeper you get, the more force the ground can resist. So this is quite a good system because these blades can then push against the ground in the deep. Compared to these earth nails, in this case, they try to rotate, of course, and so they try to move the earth around on the top here. So they are not that durable, but if you use a lot of them and make equalization, you can also rig good slack lines with them. They have a big advantage. Sorry. Yeah, they have a big advantage. For example, like here, used at Burn City Slack. When you take the poles out, the earth nails out, you only have very small holes inside, compared to earth screw, where you usually have a hole like this in the ground, roughly, which you then have to close again, but it doesn't look that good. Another possible thing for temporary anchors are, for example, deadman anchors with wood. In this case, it's planned to dig them 1.8 meter deep into the ground. In this case, they hold quite much. But please never forget that wood also rots or gets molten. So after a while, when it's getting wet and dry, maybe these deadman anchors out of wood don't hold up anymore and have to be replaced. Since it's really hard to inspect them, it's not that easy. So next thing is we go to anchors for highlines and midlines. They usually have medium tensions. A higher precaution is needed because your life is on the line in this case. You have high side forces due to wind or surfing, or, for example. And of course, the longer the line, the bigger the wind forces are. Here we have an example of a concrete foundation anchor at Moleson in Switzerland. It's a big concrete block with two steel slings, steel loops on top where you can attach your slings. Another possible system which has never built before, as far as I know, are, for example, micro poles. They can hold up a few tons, but of course you need good workers and good. Yeah, I can't find the word for it now. Special equipment to build this stuff. Here's a short draft of these concrete foundations. In this case, the numbers are not from the Moleson Foundation. They are from a planned project in Innsbruck at the North Chain, which unfortunately also doesn't get built. It has a height of 1.5 to 1.5 meters. With this numbers, with this dimension, it's possible to rig up to 2 slacklines, 2 highlines at the same time. Also with high wind forces, it's possible. The earth values, I mean, every underground is a little bit different. So the earth values we have calculated here are normal values for normal compacted ground. Here's the force of the slackline going away. This is the force of the own weight. And of course, due to this distance here, we have momentum also. So this all have to be taken into account. Just a short picture here. When a foundation breaks, when it fails, and you have a certain earth ground breaking figure. In this case, it can look like this. This is calculated with a geotechnical software. It doesn't have to be like this, but it's most probably like this. Yes, you can see the few meters before, as the slackline goes in this direction, and the few meters in front of this foundation is also very important because the earth ground breaking figure goes like this. So all of this earth here moves when this foundation fails. So always leave some space in front with good compacted earth. Here on the right side, you can see the tensions, also the tension below the concrete foundation. You can see the tension gets lower and lower very fast until it reaches 0 around down there. So when you have the possibility to compact your ground below your foundation, very good. This makes the foundation way better. And of course, for official parks, not just highlines, also for other stuff, this stuff gets tested, usually by different companies, not by the same company who built it, of course. And in this case, I got the test values of the Moleson concrete foundation. I don't want to go too much into detail because the time is already close now. But there are a lot of things which have to be taken into account. And only when everything fits, then it's allowed to use it as a highline setup, for highline setups. So the highline anchors in Moleson are super safe, I can tell you. Another thing which how a concrete block or concrete foundation also can fail is, as maybe most of you already know, there was a fatal accident, a very sad accident, where concrete block failed by rotating. A highliner died back then because of this. So in this case, as I mentioned, the block rotates away. At first, it was rigged with a sling basket configuration around here. very close to the center mass of the foundation. Then they rigged it differently, a little bit above. This means that the distance from the center mass to the attached point gets bigger and bigger. Therefore, also the momentum gets bigger. This causes the block to rotate. So this is kind of failure, as for example, this can be a kind of failure. Yeah, and this was already it from my side. I hope you got some good information from it. And yeah.
Flo, for this nice overview of different anchors for slackline parks. I think I would like to open the round for questions. Does anybody want to ask Flo or somebody else in the chat about slackline parks and horses and anchors and so on? Shoot out with those questions.
One thing that, sorry?
Peter has a question.
But you can say one thing first if you have it on your mind already. I remember my question.
Okay, yeah. Now, one thing I forgot to mention is when you want your city or your local community department to build a slackline park, it's the best to present them something which is very, very easy for them to do. For example, this, a pole system like this, a wooden pole system. They can make this stuff by their own. They have usually a Bauhof, a construction department, or something like this, where they can make this stuff by their own. For example, this is why I also planned it like this, so a city doesn't have to spend a lot of money on it, mostly on the materials, or a completely finished setup like this from Slacktivity, where you basically can buy everything in once. So that was already it.
You had one slide where you showed a concrete block on a slope in the middle of the talk. Yeah, there. And you have your point of attachment in the middle of the block. And at that point, I was already thinking about the example that you showed in the very end. Wouldn't this create more momentum than if you had it further in the front maybe or somewhere? What's the reason to attach it there?
This was just a very short draft here. I didn't get the real one. The best would be definitely to have this line here of the slackline going through the center mass here. Definitely. In this case, you have less of momentum forces, nearly no momentum forces, which makes it way better. I totally agree with you. You can get the momentum forces nearly completely away by changing the attachment point in this case.
Thanks, Peter. Thanks, Flo. Johan, you want to ask a question?
Yes, thanks, Florian, for your presentation. Like we recently got a slackline park, well, 3 poles here in the city, 3 wooden poles. And it's like you said, it's to get them higher than 1 meter was no option, because you easily get into the playground rules with all the with all the hassle, and everything needs to be super safe and not like you want it mostly. So how would it be actually, maybe there's something for the ISA, like how we can get around these playground rules, because play are getting too safe sometimes. Like even a pole of 2 meters would be like a lot more fun, but it's not allowed, because then you can make it higher and get dangerous, blah blah blah. You need all these rules. So how can we get around it? Like, because now the poles, they are 1 meter. If you want to ever get them higher, forget it. Or you need to make it different. So.
Yeah, that's the same problem we are dealing with since 2014. The fucking playground norms. What we try to do is to convince, the city department that only because you rig above the anchor point above 1 meter doesn't mean that you're balancing above 1 meter, because the fall distance height is calculated from the person's lowest point to the ground. At least that's what it's written in the rules. So when you rig on 2 meter high anchor points, but you only walk in the middle 10 centimeters above the ground, this shouldn't be a problem. If it's possible, try to convince them. For us, it didn't work. Another possibility is to tell them, okay, we want a park built not in account of the playground norms, but in account of a sport norm. We want a sports park to be built because, well, slacklining is, at least for us, a sport, also if it's not officially a sport in most states, most countries. Try to convince them maybe that this is not just a playground, it's a sport, and therefore other norms apply. Therefore, you can also make, for example, bouldering blocks. They are also sometimes in the sports norm, so you can climb up to 3 meters, maybe 4 meters high with a normal mat down below, or with normal gravel on the ground, or Rindenmulch, I don't know the English, but some soft stuff.
Okay, yeah, true. Okay.
I wish you good luck. I wish you a lot of luck. I hope you have more good news than we have here.
I will see in, like you said, the now wooden poles. So I guess within like 5 years, they will like starting to rot. We need to replace them.
Yeah.
So we'll hopefully get something better, bigger.
Yeah, give them all the tips you can. In the end, it's something new for every city department or every local community to have a slackline pole here, because the slackline poles, they receive way more forces, therefore way more deformations, and therefore they start to rot a little bit faster. They start to get old a little bit faster. Tell them they need to place something on top of the pole so the water can come in the Hirnhold side. I don't know. I'm sorry, my English is really bad.
Yeah, okay.
So as Flo mentioned, the key is to convince the city that slacklining is a sport and not a playground activity. Other norms apply.
Yeah, thank you indeed. That's a good tip.
Laurent, you have a question?
In fact, we had another experience in Brussels. It was kind of another case. Like, it was the city that came to us to build a slackline park. So we didn't have that issue, but like, it's always a problem to have a good communication with authorities and not really authorities, but also cities, and working with cities, because I don't know if it's like this everywhere, but they don't communicate really well. And if you say that it needs to be done one way, if you are not there and you are not always behind them, that will not be made the way it needs. And that's also a problem. So we have awesome slackline park in Brussels with 10 poles. It's a Robinia wood pole. There is 5 small kind of pole, but it's 2.5 meters pole with 1 meter in the ground. So it's 1.5 meters over the ground. And there is also 5 big poles from like 3 to 4 meters and a half poles, and it was mainly for long lines and tricklines, and we wanted them to put at least 1.5 meters in the ground, and they put the first one 1.5 meters, and after they said, oh yeah, it's too much work. We
can understand the last sentence.
Yeah, we will put them all at 1 meters in the ground. So we have now like the big poles with like nearly 4 meters above the ground. So it's possible to put really high, even like a rodeo line. But if you put a rodeo line at the top there, so you have no tension. But it's like so high that you can feel the movement of the pole, and it's like 40 centimeters of diameter robinia wood. So it's like really, really big, and really the wood itself, it's really strong. But it's really big. But the pole can move. I mean, it's because of the height, but it's also only 1 meters in the ground, and we don't really know what they did like with the concrete, because we asked to have with the authorities, we asked for pictures and they only sent, because we couldn't be there that day, the only day we couldn't be there. And they did no picture. We had only one I could show you, and it's like not really what we said at the beginning. So of course it's strong, and we already set up a trickline at more than nearly at 2 meters high on the big poles there, and it's not moving at all. But I mean, for to be really durable and to be really sure that it's safe, because it will be used for everybody, and you have like 4 meters poles. So it can be.
I think you're mentioning one of the key challenges, and that is that we don't really have companies out there that provide the service of building slackline parks. So we have some companies that basically deliver some product, but then it has to be built by the city or somebody else that has no clue what they're doing. And most of the slackline parks are freestyle, so they're just built by somebody from the slackline community, or maybe even somebody outside. So I think actually, honestly, this is a huge business opportunity. I look at all the slackline all the skate parks, look at all the calisthenic parks. All these companies are now actually, they're coming into the slackline business, and they're starting to offer the service of building slackline parks, whereas I hope that there's going to be more companies within the slackline community that start building proper parks for advanced slacklining, for beginner slacklining, for competitions, for everything. So I think we are at the start here. Nobody really has taken up this business path yet, and I hope this changes, because something that was not mentioned, Flo, by you, is that the reason why we are doing this with parks is because most cities have the problem that they're not allowed to rig the trees anymore. So trees are getting more and more forbidden. We need to move to parks in urban areas at least. And if we don't have a permanent slackline park in your city, you will not be able to slackline in 5 to 10 years. In some cities, at least, this is already the case. As soon as they built the poles, they said, okay, now you're not allowed to rake the trees anymore. So this also needs to be a part of the discussion when you build a park, to not have them disallow trees. So it's a big challenge. I think it will become more and more important, and definitely a big business opportunity for somebody that wants to start build slackline parks on a professional level for all kinds of slackline.
Yeah, that's true, and I totally agree. But it can also create some more difficulties, because they already it's already a big park with a lot of playgrounds and other. So in fact, that's why we needed to use that kind of poles and other, because they had already some contracts and other for this kind of stuff. So we couldn't make it another way. We needed to use that kind of poles, of wooden pole, so it was easier and probably less expensive for them to make it this way, even if I'm pretty sure to have that kind of pole is really expensive. Because to have a 4 meters and a half robinet pole of 40 centimeters of diameter, it's really expensive. But
that's another important thing. I think we shouldn't try to build our slackline parks as cheap as possible. I think there are possibilities to raise money within the city, within the community itself. Just as an example, the cash flow for these 2 poles in Dalmati Park, like the waterline poles, is 20,000 euro. That's the cash flow. That's without our work, anything.
How much?
20,000 for 2 poles. So just to say that, I know we're in Switzerland, it's a different money game, but just to say, I'm sure that you have possibilities to raise money, maybe not this kind of money, but a couple €1,000 for a good slackline park in your city that will hold for 50 to 100 years,
Yeah, true, yeah.
So if you have your infrastructure set up, good infrastructure that costs a little bit something, that doesn't have to be replaced in 5 years, I think it's actually worth it. It's gonna help the community for the next 50 years if you do it right.
Yeah, that's totally true. But at this place we had also the problem that we couldn't. They didn't want to use steel because it's a really big green park and with classified trees and other also. So it was only wood and that's it. So
but there also I think Cologne is one of the cities that showed that there is some medium ground. So you can build poles made of steel for long term and fit them around with wood. And actually these plans are all open source. So the solution from Cologne is, you can just Google it. It's online. It's a master or PhD thesis of one guy that calculated all the poles. So you can show all these examples to your city, and I think it's actually a nice solution for. You can even rig trick lines. You can rig rodeo lines off these poles, and they're really long term.
Yeah, true. Yeah.
Okay, I think we shouldn't make this much longer unless somebody has some important question for Flo or somebody else in the chat.
Yeah, it's just one idea, but it's more like when I suggested a slackline park to the city, I also was thinking because they first did the metal poles and blah blah blah, so they chose the wooden poles. But I said what if you also plant trees at the same time? In the sense that actually within several years, when the trees get big enough, you can use the trees instead of the poles, and eventually the poles will, because they're wood, they will degrade, rot, and go away. So you don't have to, you actually after 5 or 10 years, I don't know how fast the tree will grow, depending on the site, blah, blah. But then actually you're making a more sustainable slackline park, I guess. I mean, of course, if it's metal and stuff, it will last also 50 to 100 years, like you said. But if it's wood, then, what do you think of also planting trees for the use of slackline?
I definitely agree with you. It would be more for long term. It would be way better. The problem we experienced here in Austria was when we wanted to touch a tree in the city, they told us that they will sue us. Because simply a tree is worth a lot, like 20 to 50,000 euro per tree. It has a lot of.
But the tree is planted with the purpose of being used for slacklining. So it's a gray area, of course, and eventually a tree is a living thing and stuff. But
and you should calculate I would say 5 to 10 years when the tree is already big when planted in before you can rig a slackline on it.
You're right.
So it's quite a long-term thing, but I totally agree with you. The next down point is that not everybody uses a tree according to how it should be used for slackline. I mean, tree protection is one thing. The other thing is also to, when a tree is getting used every day, also with tree protection and so on, and always it will be put away. So no permanent installation. Also, this already makes some marks on the bark, which is not that harmful for a tree, but you can see the marks on the tree. And I think this is also something which they want to reduce or not getting these problems at all. So they try to place some man-made stuff, which can be used like slackliners want to use their poles. So using a tree permanently every time again, also you can see it on the tree's bark.
Yeah, I know it's also not the best solution for like visibility purpose, but in Switzerland, if I'm not wrong, or in Germany maybe, they put some wood around the trees to protect it from abrasion and other. So it's also a good solution for me, like to have like dedicated trees like this, and they are really protected, so nothing can really harm them. So
they are harmed. Actually, there's lots of studies on this. Like if you put these wooden poles around, like maybe we can pull up a picture, Flo. If you put these wooden frames around trees, it will destroy them. As soon as you have to move it around like every month or so to not destroy the tree. If you remove it after a year, the tree is either damaged or it looks horrible. You cannot like look at it anymore. So this is definitely not a solution to have these wooden cages around trees to protect the tree itself. They thought it was a good solution, and in the US they also recommended, like in Yosemite National Park, to put little sticks underneath the line. You can do this as like a temporary thing, but as soon as you do it permanently, you will also destroy the bark of the tree. You will create pressure points where the bark will get damaged.
This system, right?
Yeah. Exactly.
Yeah. I think there was even a study which showed that it's harmful for the tree.
Yeah, so this was also in Cologne. They used these and these permanent anchors, but then they got away from these because they damaged the tree a lot.
But it's also the same for the trees, parkour stuff and other. It's like really permanent in that kind of parks. So, and there is a lot of possibilities, and with really high tension when they have like Tyrolean and other stuff like that, there is like more than 1 ton tension, like permanent on the trees, and they are not really.
You can do this like this is a classic way of protecting your tree, like in a ropes park.
Yeah.
Right, but not in a public city park. It's something completely different. You have to separate the two. One is usually done in forests where the tree is worth the wood of the tree. In a public park, as Flo said, each tree is worth 20 to 50,000 in Central Europe. And as soon as you damage just optically the tree, it's not worth anything, and you will have to pay it. So no, it's not really a good solution, in my opinion. Peter?
Do you guys know these, in a lot of playgrounds in Germany, they have these things where you ride along a steel cable over a park. Do you guys know if those forces are comparable? And there it's clearly a playground, and they still measure the fall distance from where you're sitting, which is not that high. Could that be a good argument for anything, or does the structure compare at all to anything one could do with slacklining? The forces?
It's not that different. The difference is that also usually the whole underground needs to be padded with like wooden bits, and then they usually use some sort of A-frame and concrete anchors, and they're very expensive to create, or maybe as expensive as Slackline anchors, but they definitely compare, yes.
I mean, you see them all over the place, at least in Germany, I think. and they often don't have any wooden padding, like grass underneath or anything. And often there's no grass underneath anymore because there's so many people, whatever, stopping and jumping off and running back and forth. So it's just the ground that used to have grass but doesn't have anymore because too many people are running over it. I don't know if for just an idea of another argument, of another way of convincing somebody that this is comparable to things that are already there.
Okay, thanks a lot for everybody's input. I think we'll end this presentation for now. The next presentation will be in an hour from now, so there's another lunch break, second one, with Jan Mattis presenting about cyclic loading weblogs, the study he did for his thesis. And after that, Yoshi and Lorenzo have a presentation on stretch curves of webbing. Very interesting topic as well. So join us again in an hour. Thanks a lot, everybody, for the nice conversation. Hope you join again in 1 hour. Have a good one. Thanks, Flo, for presenting. Great.
Thanks for having me. Bye.
Bye-bye.